Good day, ladies and gentlemen. This is Sarah van Geen, aka Mr. VG, and man, I'm excited to be here with you today. I cannot actually believe that 2021 has gone by this fast. Oh my goodness, we're already looking at exam preparation. For most of you, that's going to be happening, this amazing exam in the next, month? 2 months, depending whether you're IEB, GDE, I don't know what all the other acronyms is, but let's leave it there. So what I'm excited is for today to do paper 2, maths. Loving it. Now this is one of my favorite sections in mathematics. I love this paper simply because it's weird. Okay, it's really, really weird. So let's have a look at going through what is actually asked in the paper. So I'm going to structure mine a bit different from Mr. Tengo, who did paper 1. If you haven't watched his video, please watch his video, an amazing video about paper 1. I'm going to start this by just looking at the scope. First of all, statistics. Now, I just quickly want to say this is not the order in which it will be written. Order is going to be different from whether you are a DBE student or whether you are an IEB student. It differs. So, statistics, about 20 marks, plus or minus 3. Trigonometry, 50 marks. Now, please pay attention. This is the one change in the 2021 and onwards. Usually it was, Euclidean Geometry was 50 marks and Trigonometry was 40 marks. But this year they decided, let's flip it around because there's so much more trigonometry to ask. But I think also it's got to do with, this is my humble opinion, that there's a lot of score marks in trigonometry. And kids struggle with Euclidean geometry. That's just my opinion. What I've seen. Man, let's get into this. Analytical geometry, 40 marks. Euclidean geometry, 40 marks. But I am going to warn you. They can mix it up. Nothing is stopping the examiners from throwing maybe some trigonometry inside a traditional Euclidean geometry section. Nothing stops them from maybe mixing this up. It was actually awesome. I think it was a year or two ago that the IEB examiner started a question as being a Euclidean geometry question. And they asked some questions about halfway through the paper, halfway through the question. Let me get my wording right there. Halfway through the question, they flipped this over onto a Cartesian plane. And the kids freaked out. What's going on, sir? All of a sudden it became analytical geometry. So, this is the guidelines that we use for you to study. Now, paper 2. I love it. It's a question paper that's got some difficult concepts. But if you are prepared enough, there is a lot of score marks if your approach is correct. So how I'm going to approach this video is by looking at, first of all, the content that you need to cover. And when we're done with the different content, we are going to have a look at common mistakes, some big time tips, and we're going to finish off this video by specifically looking at how do I approach this next 6-7 weeks of the exam or before the exam. So let's start with statistics. Oh my goodness, I love statistics. Statistics is score marks, but there's actually a lot of work that goes into a statistics paper. A lot of stuff. If you just look at the graphs, there's 1, 2, 3, 4, 5, 6, 7 different types of graphs that you can be asked. Which one are they going to ask, or which two are they going to ask? Honestly, we have no idea. I can tell you today a calculated guess, which is box and whisker, ogives, scatter plots. The box and whisker and the ogives usually run hand in hand, especially these days, because they want to see, do you understand? But please don't forget about histograms and frequency polygons. Histograms and frequency polygons, they go hand in hand, but I have found many students confusing what happens at a frequency polygon to what is happening on an ogive. So please, I'm asking you, I am imploring you, do not forget to study both and know the differences. Linear regression, now that's matric work. Guaranteed to be there. They go hand in hand with scatter plots. Now, linear regression is all about finding that line of best fit. Now, in statistics as a whole, there are many different models that can be used. But for our curriculum, we just look at the line of best fit. The correlation coefficient will be asked, and very important, the interpretation thereof will be asked. Interpolation and extrapolation, now that does sound something to do with pollen, but it's about guessing, calculated guesses. Interpolation meaning if they tell me that I've got a range of data going from age 5 to 15, that's interpolation. So if I ask you how much did a kid at the age of 10 weigh, that is interpolation because it's in between the 5 and the 15. But what if I now ask you about the kid at birth? Whoa, that's extrapolation because it is outside of my 5 to 15 range. So when I look at this, I've got to just be very careful with the way that the examiners can ask this. Dispersion will be asked in some form. But the examiners have kind of gotten sneaky on this. I'm being very honest with you. They're going sneaky. They're not just going to ask you, determine sigma, determine this. Now they would give you two different sigmas and they tell you which one is better. Which person performed better? Which person would you pick, for instance, to go and play in the cricket team or in the soccer team? Man, you've got to be able to interpret this. Not just calculate, but interpret and understand. If you are getting stuck with this and you're like, oh man, what is this teacher talking about? Please, you've got time. You have time to go to your teacher or go find some of the videos online that speak specifically about standard deviation. Skewness is also a topic that's asked every single exam. Whether something is skewed to the left or to the right, in the positive or the negative, that you have to do. But we'll have a look at this a bit later on. Central tendencies, mean, mode, median. How will they ask it is the bigger question. How they love to ask it is to mix mean and median with skewness, because it's actually outliers skew data. So in other words, if I have a large outlier, it pulls my mean away from my median. If I've got a small outlier, it goes and pulls it in the other direction. So the mean and the mode together with an outlier gives us skewness. Now, please, this is not the exact mathematical definitions about what is an outlier. There we can talk about, over a cup of coffee for about 2 or 3 hours about what's a proper definition of an outlier. But let me go on to more work before I get stuck here for the whole 1 hour. Next up, we've got analytical geometry. Now, analytical geometry, oh my goodness, is beautiful. Because analytical geometry, you've got to be careful of, is they can throw together anything from algebra, trigonometry, to Euclidean, anything they can ask in there. What are the basic formulas you've got to know? Grade 10 work, distance, midpoint, gradient. Wink, 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 nudge, nudge. Don't forget about collinear. I'm talking to you now there. Don't forget about collinear. Collinear, when 3 lines lie in a single straight line. It sometimes pops up for a random question. Don't forget about it. Inclination angle, I'm not going to talk about much at this moment. Maybe in 2 or 3 slides, we'll have a look at the inclination angle and exactly the difficult questions. Grade 12s, please pay attention. Quadrilaterals, oh my, we catch you guys out every single exam because you guys forget to study the properties of a quadrilateral. You forget to study all the different properties, say, of a rhombus. Now you might go and say, oh, so where do I get this? Well, let me give you a tip. Go to your teacher, find a grade 10 mathematics textbook, and they usually have one beautiful page of summaries that summarizes all the properties of the quadrilaterals for you. Because if you take a rhombus as an example, you as a student have to know that the 2 diagonals will be perpendicular, which means, going back to gradient, perpendicular lines. The product of the gradients must be -1. But what if you forget about this? Well, then you're going to be stuck. I'm telling you now, you're going to be stuck. So please go and study the quadrilaterals. Circles. Oh my goodness. I love it. Because now I can start actually mixing circles up. I can bring in all my Euclidean geometry questions and mix it up with algebra. That's the beautiful part for me about analytical geometry, is I'm, creating this big smorgasbord, this big cauldron of mathematics, and I can throw in everything. With circles, standard equation. You can be asked straight off. Here's a midpoint. Here is a coordinate. Determine the equation. Or they give you an expanded formula and ask you to rework it in here. And that's why we do completing the square. Let's look at tangents. Oh my goodness. Theorem 7. I like to call it Theorem 7. Some of you don't like to call it according to numbers. But Theorem 7 says a tangent must be perpendicular to a radius. So in other words, the gradient of the tangent must be times by m2 to give me -1. I just see a mistake on my slide. Oh my goodness. I'll fix it before I send it out to you guys electronically. The line from the center to a chord. What do I mean by that? That means if I've got a line from the center of a chord, it must, if it's perpendicular to that chord, it will bisect the chord. So if it is perpendicular, it will bisect. But if it bisects, it will be perpendicular. Again, linking to the product of gradients. And here's a nasty little thing. And I'm saying this is a nasty little thing because I can ask you any of the other 9 theorems in Euclidean geometry. I can actually ask it of you. So let's quickly have a look at the next slide. Trigonometry. Now, trigonometry is, I think, one of my favorite sections in maths, simply because of the amazingness of it. I don't even know whether that's a proper English word. I'm just making this up. But how amazing trigonometry is, because when I look at trigonometry, trigonometric functions that repeat, trigonometric functions with amplitudes and periods. Oh, I love it. There's so much here. So much. In trigonometry, your theory basics, I cannot stress how important it is. Ladies and gents, please, 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 please make sure you can do the cast diagram proper. You've got your special angles down. Now, some of you might go and say, oh, but sir, I can use my calculator. Why do I need to know this? Well, those of you that are going to study engineering, calculus, you are not allowed to take a calculator into the exam hall. What are you going to do now if they ask you a special angle? Some of you that haven't written your NBTs yet, you're not allowed to take a calculator in. So please go and study your special angles. Don't forget about the quadratic equation or the quadratic trigonometric identity, as well as your tan, your quotient identity. Then we get to compound and double angles. We're going to talk about this a bit later on. Cofunctions, I've highlighted that separate because every single exam I see my students struggle with it. Every single exam, they forget that 90 plus now becomes a second quadrant. They forget that minus 90 is in the fourth quadrant. So please remember, with the 90 degrees, if I see a 90 degrees, my sine is going to change to cosine and my cosine is going to change to sine. But then that has to be connected to the cast diagram. Then we get to equations. I've just highlighted on here because if I had to spend this time explaining all the different types of trigonometric equations and how to deal with them, we'd be sitting here till tomorrow morning. So let's quickly just run through the different types of equations. Type 1 is a simple equation like sine x equal to a half. You have to know how to solve that using the cast diagram. Type 2, I've got sin and cos, but with the same angle. Not different angles, the same angle. That's important. Because once I've got this, I could divide by cos of that angle straight through. If I've got sine and cos with different angles, oh my goodness, matrix. This is now crucial for you. Be careful of expanding when you get a sum like this. Because they love to give you one like sine 2x equal to cos x minus 30. Now you get trigger happy. Expand, expand. And you get no marks. You have to go back to the drawing board. Go and watch those videos that are available on the Junior Tiki online platform where we go through how to handle this. Type 4, which is quadratics, where we start bringing in algebra. We could also just as well throw in a quadratic equation there if we want to be like really nasty. Why not? Part of trigonometry, and this is why I say trigonometry is the easiest place to score marks, is there's only a handful of types of sums that you are actually going to be asked to solve. The first one is a Pythagoras type of sum. You guys must know this by now. Come on. If 5 sine theta is equal to 3, solve the following solve this without use of a calculator by using a sketch. There's your steps. I'm not going to talk through it. There's some amazing videos on our platform about it. What other types of sums are there? Well, what about without a calculator? So writing in terms of sine of 18 degrees is equal to k. Write the following in terms of. Please go and watch some videos online for that. Simplification. Now, I want to quickly just talk about, I'll talk about it a bit later on if you excuse me. I'll talk about it a bit later because I get passionate about this and then I get sidetracked. But you've got to be able to work with special angles, cofunctions, compound and double angle identities whenever you are asked to do a trig sum without use of a calculator. Now, I'm going to give you a nice little tip. There's about 4 steps whenever they're asking me to simplify. Number 1, get your angles between 0 and 360. Number 2, get your angles between 0 and 90. Number 3, special angles. If that does not work, you are either going to go to co-functions to try and get angles the same so they can cancel out. If you're really mathematical, we don't like cancel out. They divide away. Or sometimes, especially now with the matrix, we can ask you to use compound and double angle identities so that you, in any case, end up with a special angle or a cofunction. But that's kind of my last step with that. With proving identities, now please understand what I wrote down here is the 5 or 6 basic steps. I am putting these steps out there not as being the Bible. This is not, it will work everywhere. But it works for 90+% of proving identities. Number 1, change tan into sin and cos. Then sine of the double angle becomes 2 sine of that angle and cos of that angle. Why do I not include the cos double angle? That's a good question. The answer is simple. A lot of times, in your first step, you will not know into what you've got to change it. Sometimes you are going to be, so must I put it into causes and sins? Just causes? Just sins? We don't know. And if you change it into the wrong one, well, it's not that you're not going to get there, but you're going to try and get to Cape Town by going to Cairo. You will get there eventually. But the problem is it might take you much longer, and time is of the essence. So I leave my cos double angles until step 3. So after I've changed, I go to LCD, lowest common denominator. Usually after I've done my lowest common denominator, then I only change cos. Because then I look on the other side of the equation. What do I need? Square identities then follows, but please try and make your sum smaller, not bigger. Bigger is more complicated. Factorization is a very important thing. Now, I encourage you to please, when you use factorization, if you're struggling, use the K method. Use the K method. Make cos theta equal to K, but do it on the side. Do it on the side. Once you've done it on the side, you can always substitute back, and you then go, woo, things just divide away. Oh my goodness, sir, I get to the right answer. I've seen this work countless times. If the first 5 steps don't work, then you start praying. Because then you need a manipulation. Okay? That is very seldomly asked. To change 1 into sin squared plus cos squared, or where I've got to multiply by a fraction where the denominator and the numerator is the same. You can go and practice this at your own peril. I'm not going to spend much time on solving triangles, but I'm going to give you one tip with solving triangles. Just one tip. Always break up your sketch. If it's a 3-dimensional sketch, break it up into the different triangles. And then you go and you apply the sine, cosine, and area rule in a non-right angle triangle. In the right angle triangles, please stick to SOHCAHTOA and Pythagoras. If you don't know what SOHCAHTOA is, please come in contact with me and I'll gladly enlighten you. Let's move over to my last amazing section, Euclidean Geometry. Oh my goodness. Oh my goodness. I love it. As you can see, I'm passionate about most, if not all, of mathematics. But Euclidean Geometry, there's a lot of studying that goes into this. You've got to be able to know all the different shapes. So we've got lines, grade 8 and 9 stuff. You've got triangles, grade 8 and 9 stuff. Then you've got grade 12 triangles. Ooh-wee! Grade 12 triangles become fun. But something I'm going to encourage you is before you look at grade 12, first make sure that your grade 11 circles are 100% done. Because if it is not done, if you can't do this, I can guarantee you're going to struggle with advanced triangles. Because almost all of advanced triangles, except maybe our proportional line theorems, depend on you starting a sum as a circle. So when I specifically have a look at proving shapes, now this I included because when I look at my grade 11s and 12s, every single year, my students come to me, "Oh, sir, how do I prove parallel lines?" Now, I just want to almost say hit the pause button in this section. And I want to just quickly for a moment talk about something that I had a professor come and speak to me, not specifically me, but in a group, in a conference about. And this is a lady that worked in, or that's working in the University of Stellenbosch. I just forgot her name now. But she came and spoke to us as AP Maths teachers, and she said, one of the reasons why first year varsity, 50 to 60% of first year varsity students drop out is because number one, their math toolbox is empty. There's not enough theory that went into it. Secondly, it's unorganized. There's a complete chaos. In other words, when we are talking about how do I organize it, it's about I don't look at all my theorems the whole time. I look at certain pockets at certain times. And I create those pockets when I study. So when I study, I ask myself, how do I prove parallel line or parallel lines? Then I only look at those 4 theorems. Either proving corresponding equals, co-interior angles are supplementary, or alternate angles being equal. There's no other way. Or the line dividing sides of triangles proportionally. That's a new way. That's a grade 12 way. These 3 is grade 8 and 9, grade 12. There's only 4 ways to prove a parallelogram. Now, I am saying this just very, very clearly. These are not the only ways of proving a parallelogram, but they are the generally accepted ways. Opposite sides are parallel, opposite sides are equal, opposite angles are equal, or one pair of opposite sides are parallel and equal, diagonals bisect each other. Which one am I going to use? It depends on the scenario. Cyclic quadrilaterals will be asked to prove. Tangents, oh, they love it. So I'm going to tell you again, if they ask me to prove something is a cyclic quad, there's only 3 ways. To prove a tangent, there's 2 ways. Either have that weird one where you've got kind of a tangent and that line must be perpendicular to the radius. Man, it's a weird one. But I've seen it asked once in a million years. But Theorem 9's converse is asked almost every single exam. So when I am approaching a Euclidean geometry sum, I don't look at this. There's 1, 2, 3, 4, 5. Then there's another 5 there, so 10. We're talking about 12. There's another 9 plus the converses. We are talking about an excess of 40, 50 theorems just on these 2 slides. If there's maybe even some that I didn't even put on here. I don't look at all 50 at once. I look at, but which one is applicable to that situation, and I only open that pocket, take out what I need. When I'm done, I put it back up, I zip up the pocket, and I move on with my life. This is the basic theory you need to study for paper 2. There's a lot to study. I'm just saying it. Putting it out there, like way out there. There's a lot of studying. So please do not leave it for a week or two before. And also, don't leave it for another 2-3 weeks and go, oh, sir, I studied hard for prelim, I'll be fine. No. Every single day, you have to go through these theorems. Let's start looking at common mistakes. It doesn't help, ladies and gents, if you just study your theory, but you make silly, small mistakes. So the first one that I want to talk about is ogives. Let's say I've got this example. A group between 30 and 40, 40 and 50, 50, 60, etc. with a cumulative frequency. They ask me to draw an ogive. So when we're talking about drawing an ogive, this first graph highlights two common mistakes that students make. Number one, they use the wrong points. Now, if you're quick on the uptake, you'll tell me what is wrong. What is wrong? They used 35, 45, 55. But that's the middle values. That's not an ogive. You have just confused yourself with a frequency polygon. A frequency polygon works with a histogram, and they use middle values. So please don't do that. The second one is this graph kind of hovers in the middle of nowhere. That's wrong. It must be grounded somewhere. Because if you don't ground it, you are telling me that there's nothing happening below that little point. There's nothing. Well, that's nonsense. So that's wrong. How must the graph look? Well, roughly like that. Now, please understand, there's a bit of contention, I'm saying this very clearly, amongst mathematicians. Must it be grounded at the 30, at the start of the interval? Must it be grounded halfway through? Let me make it very plain and simple. It must just be grounded, I prefer, at 30. What that means is because the graph stops there at 30, that there's no data that lies below 30. So please don't go and ground it at naught. Because if you ground it at naught, it means that somewhere there might be one person that actually got between 20 and 30 or between 10 and 20. That's not the truth. So please ground it at the beginning of that interval. Every single exam, kids lose 2 marks for this, 2 out of 3, because they use the wrong points and they don't ground the graphs. Please, 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 for your own sake, don't do that. Some big time tips. The effect of outliers. Let's just quickly talk about I'm going to say it's a very airy-fairy, up-in-the-sky definition of what an outlier is. It's not this I'm giving you now is not a formal definition, but an outlier is a data entry that does not fit the rest of the data. It's usually very big or very small. There are some formal definitions, and it depends on who you ask. So that's why I'm going to say I'm not going to go into the big detail of outliers. But what effect does outliers have? Well, outliers skews data. So if I look, for instance, at this, I can not very clearly see, but I can suspect that 45 is maybe an outlier, but I would not be 100% sure. But what if I put a dot like here by 10? Well, that I could say is an outlier because it really doesn't fit anything else. Or if I go and put one there by 150, that would be an outlier. Now, how can the examiner ask this? Well, they can ask you, If I put that dot in there as 150, what does it do to the mean? What does it do to the median? What does it do to the standard deviation? That's the kind of question that we love to ask. If I take, say, this top 85 and I change it to 185, that's a beautiful question, in my humble opinion. It becomes an outlier. It's now going to be like somewhere there. So if it's somewhere there, what's the effect that it's going to have on the median? Well, nothing. Because the median is still going to be in the middle of the data. But now I've got a really big number. What's the effect going to be on the standard deviation and the mean? Well, it's going to increase. Because now I've got a really big number. So what I like to do with outliers is I like to think of an outlier as being this elastic band. If I take this elastic band and I pull it, it's going to pull the data to that way. It's going to pull your mean that way. So it skews the data all this way. If I say data is skewed on the skewed left, it means the data on the left of my data set is more spread out. So it pulls my mean to the left. So my mean is now smaller than my median. If it is skewed to the right, it means my data is spread out to the right. In this case, it's specifically skewed left. Typical exam type question. What's going to happen if I remove an outlier? Say, for instance, there's a minimum and a possible outlier. What's going to happen? Well, again, think of it. Now this elastic band is pulled tight. What's going to happen if I let it go? If I let this thing go, everything moves. So what happens if I remove an outlier is the rest of my data now becomes more accurate. So in other words, the correlation coefficient is going to be closer to 1. My line of best fit is going to be better than it was before. Another kind of question that they love to ask is, what if we take some points and we move it? Now you have to, in that situation, ask yourself, will it have an effect on the middle, the median? Because it will affect the mean will be affected. But if we move all the data, well, standard deviation is not affected. Because if we move all the data, the spread of the data is not affected. It's just the mean and the median that gets affected. So be careful. You've got to think the whole time about what it means. Let's look at trigonometry. Oh my, I love trigonometry. The first common mistake I have found is powers. Say I've got tan to the power of 4. Please move the power outside and then you do your reduction. Don't leave it in. You're going to forget that actually, even though it's negative tan 45, but it's a power of 4, so it becomes positive. Sin squared, the same thing here. Moving it out. Now inside that bracket is going to be a negative, but if I square it, it's going to become positive. Be careful. Sign mistakes. Oh my. Oh my. Every exam we see so many students lose about half of their trig marks because of sign mistakes with reduction. You've got to understand, ladies and gents, that when I make a sign mistake, a lot of times in matric, halfway through the question, I'm stuck. I'm stuck because I can't apply the identity or the rule that the examiner wanted me to apply. I could lose half of the marks by making one mistake. I'm not joking. Please make sure that your signs are correct when it comes to reduction formula. Changing cos 2x into the wrong identity is not necessarily a mistake, but it's putting you on the long path to now try and get back to where you should go. So please, when you change cos 2x, make sure whether you know whether the examiner is wanting you to change it into cos, sin, or both. That is a skill that I'm asking you to go and practice. Another mistake is forgetting about where identities are undefined. A lot of you guys and girls get the denominators is equal to naught. And you go, I'm done. But what about the asymptotes in tan graphs? Even if it's not in the denominator, just somewhere. So I always tell my students, when you hear the words identities being undefined, look for a tan. Before you do anything else, look for a tan. Get the asymptotes. Boom, you've got 1 or 2 marks. Then you look at the rest, just so you make sure you don't forget about it. Analytical geometry. Now, when I look at analytical geometry, a beautiful question like this one, let me just go back to that, where they ask me to get a value for alpha. I have seen many an exam asking this kind of question. I mean, every exam. They would somehow either like this, however they put it. So my tip to you today is, which lines do alpha touch? It touches that line. It touches that line. That means I'm going to have to get the inclination angle for those 2 lines and manipulate the living daylights out of them to get alpha. So in this green line, the gradient is given by 2. So, if I look at this red line, I've got an issue. I only have 1 set of coordinates. I need a second set. But isn't that a special kind of question? Yes, sir. That's a special coordinate. That's the y-intercept of that line. Oh my goodness. There I've got my plan that I've got to walk. I've got to start getting the y-intercept so I can get the gradient. I've got the gradient so I can get the inclination angles. And now you use Euclidean geometry to get alpha in that triangle there. Sounds easier than it sometimes is, but it takes some practice. Another bit of big time tips from my side to you is the intersection of circles. They love it as a 4, 5, sometimes 6 marks question. Do the circles intersect? Don't they? Or do they simply touch? So what I did is I'm giving you these 3 scenarios, the 3 basic scenarios. Either it's going to intersect twice, then you have the distance between the 2 midpoints being smaller than the big radius plus the small radius. And you can read, I'm hoping. Just joking. If you read this, what are the 3 things you see in every single one of these sketches? There's a distance between the midpoints. There's a big radius. There's a small radius. So, whatever question they ask me about intersection of circles, even if I forget the small little equal and smaller than things, they are asking me for 3 things. Get the distance between the midpoints, calculate the radius of the big circle, get the radius of the small circle, And now you analyze. So if you do those 3 things, that's already usually 4 to 5 of the 6 marks. Easy, if you remember it. Now, just for being funny, I'm also decided to do internal circles. I've never seen them ask this, I'm just saying. Never seen them ask this. But it's something nice to know. You know, at a party and you know you want to impress that person, you can always throw, some maths in there and go, did you know? I've never tried it. Maybe you can try it and let me know. Let's look at Euclidean geometry as our last section to look at. The biggest mistake I found in all my years of teaching, and I feel old when I say that, but yes, in all my years of teaching, is students look at the question first. So if they've got this question, they're like, blah, 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 prove that. And then they start manipulating. And then they get halfway through, no, sir, I can't do this. This question is impossible. And they write to the Pretoria News and it can't be done. And then you get the examiner going and saying, but you missed that bit of information. They go, oops, sorry. So, what is the better approach? Number 1, mine for the information. So number 1, read through it. So let's do this example. Now, we're not going to answer the whole thing. We only have 13 minutes left. DC and DE are tangents, which means I have Theorem 7, 8, 9, which I can use. Theorem 8 specifically gives me 2 lines from the same point, an isosceles triangle forms, so I've got 2 base angles equal. Boom. First mark. I want to drop the mic, but I don't want to damage the mic. But now, I can't stop at Theorem 8. What about Theorem 9? Theorem 9, the tan chord theorem says that E2 and B is going to be the same. I could just as well go from this point, C3, and also go towards B. That is also the same. Oh, but so they're equal in any case. I know. What else is there? A is the center of the circle, which means actually I could apply Theorem 7, which says that C2 and 3 must be at 90 degrees. E1 and 2 must be at 90 degrees. I didn't even see that when I was analyzing that. But let's look at what else is there from a center of a circle. So let's stop. Center of a circle. I'm going to open that bag. My center of a circle bag says, go to the definition, which says I've got equal radii. I stop. That means I've got base angles of an isosceles triangle. I've got more base angles of isosceles triangles. That's just by looking at the definition, which says there are radii. Next up, I can go to Theorem 1. But there's no line to it chord, so I'm not going to look at Theorem 1. Theorem 2, I could look at. A2 is twice that little angle B. A1 is twice E1, if I wanted to. What about Theorem 3? There's a 90 degrees at C1 and 2. Lots of information. I didn't even put on the sketch because otherwise I would confuse you. After I've mined through the information, it tells me that B lies on the circle. So I'm not going to look at that very much because it just means there's a straight line, so it's a diameter. Formulate a plan. How do I answer this? Well, if I look at triangle ABC and triangle DEC, I want A1 to be equal to D. I want angle B to be E2. I want C1 to be 3. there I've got my plan. If I can prove that somehow, well, then I'm going to have this problem solved. I've actually got it solved already, sir, because angle B is E2 already. C1 is B, and B is C3. So C1 and C3 is already equal. And I didn't even break a sweat. Lastly, A1 and D will be the same. Why? Because of interior angles of a triangle. Now, I can actually prove the question. So please follow the steps. Mine. Open the pockets. Close them when you're done. Move over to the next. The one thing that I didn't even look at because it was not applicable here was what about cyclic quads? There's no cyclic quad in there. Do not forget to look for cyclic quads. So, where are we now? We're getting to the end of this video. And I want to try and give you some tools in your hand for you to approach the next 4 or 5 weeks and make sure you ace this exam. Because this exam, ladies and gents, is going to determine which of the future careers can you actually go for. The 3 stages consist, first of all, of preparation, the day before the exam, and then lastly, the day of the exam, the actual exam day. So what must you do in preparation? Number 1, you've got to know your theory, especially paper 2. But please, do not ignore paper 1 theory. Because there's a lot of paper 1 theory, like where stuff undefined, forgetting about rules, etc., etc. Don't forget to study those. Try and create an exam environment for yourself at home. Meaning, you do not want to sit with music blaring and dogs barking and your mom coming in to give you samis and you get lost in your music for like 30 minutes and you go, oh my goodness, I'm actually trying. What am I doing here? Oh my. Try and create an exam environment. Get a quiet space to study and work against time. Now this is the one part my students hate. It's the ABC of studies. Apply the bottom 2 chair. You need to sit for 3 hours at a time when you're practicing exam papers. And now some of you guys are going, oh, but sir, I struggle to sit for 45 minutes, then I've got to take a 2-hour break. No. You've got to train your body to study for 3 hours at a time. Otherwise, you are not going to be able to do it when you sit in the exam hall. You can't concentrate for 3 hours if you're not trained. You can ask any marathon athlete, soccer athlete, for you to get properly versed, to become a professional. You have to actually extend yourself past your exam. Like a marathon athlete, if he has to run 42 Ks, he will run 50 or 60 Ks so that he makes sure on the day he's prepared. Or her. Let me not be a his or her. You have to again work against time. Mr. Tenga said in the other video as well, you've got to go for 1 minute per mark, even at home. Train yourself. Train yourself. The day before, do not push yourself into the red. And, if I study till 3 o'clock, I'll be fine. So, no, you won't be fine. You'll be fine maybe for the first hour to hour and a half. Then you start crashing. Then you start hitting blank spaces. Please, get enough sleep. Proper sleep hygiene is important. So relax, at least an hour before bed. Put away your best friend, your cell phone. Put away that cell phone for at least an hour before bed. Your brain needs to switch off. If you're going to lie there in bed and watch a few videos, your mind keeps going, and you get less and less and less sleep. Put away the cell phone. What about the actual day? Number one, it's like Fight Club. We don't talk about Fight Club. You don't talk about the exam on the day. We all have that one friend, maybe it's you, maybe it's not, who goes, did you remember to study? Did you? I'll talk to you afterwards. And you go and you sit and you calm yourself down, because it's usually 1 or 2 marks, but it gets you so stressed up that you don't even know what your name is anymore. Do the easy sums first. Take that 10 minutes. 10 minutes sleeping, reading time. Take that 10 minutes reading time. And don't sleep, but plan your paper. Plan. I'm going to answer question 2, then 5, then 11, then 8. But please keep the questions together if you're writing on a separate paper. The reason why I ask you to do this is because it calms you down. You go, yes, I've got this. Then you hit the medium difficulty questions and I remember, sir. And then you hit the what the hell kind of questions. But by that stage, you've already scored all the marks that you can. So now you run into it, you go, I'm going to give my best. And you're not going to get stuck halfway through, hoping and praying that I'm going to get through to the end. Please, please calm yourself down in the hall by not starting with the difficult questions first. Start with the easy questions. And now I'm saying this last point, breathe. It really helps. There's a lot of research that was done about breathing techniques, but it's easy. If you're feeling really stressed, sit somewhere. 3 or 4, actually 5 is best. Deep breaths until you feel like your lungs want to explode, and then breathe out until you feel like you're almost dying. And you do that like 5 times. And there's actually chemical things in your brain. I'll leave that to this life sciences people. But there's actual chemicals in your brain that is released, and it calms you down. Ladies and gents, thank you for tuning in. I am imploring you for your own future. Give all you've got this next coming 6-7 weeks. The jol, the parties, that can wait for when you're on matric vac, and hopefully you're keeping your COVID distance and your mask and everything like I'm not doing at this moment. But please look after yourself. Make sure you get to the end of this road with no regrets. You don't want to walk out of your matric and go, oh man, I just wish I pushed a bit harder. Give it all you've got and you'll make a success of it. So have a beautiful, fantastic and wonderful rest of your day. This is Sarel van Greenen, aka Mr. VG, signing out. Have a beautiful rest of your day, beautiful rest of your year, and a successful future. Cheers.